All right, in homework 7.2, you're supposed to be first deciding whether something is exponential, and then if it is exponential, writing an equation. I'll try to quickly do this. Let's do number 2 and 3 here. Marbella buys a boat for $4,000. Each year it is worth half as much as it used to be worth. The first question is this exponential? Does it have a constant multiplier? Since it's worth half as much as it used to be, each year, what we're doing is each year we're taking half of 40,000. So it's 40,000 times 1/2. That would be 20,000. And then it's 20,000. We're going to do half of that, which is times 1/2. That's 10,000. Then we're going to do 10,000 times 1/2. And so we see there is a constant multiplier of 1/2 each year. Each year it's half as much as it used to be. And so the equation, this is exponential. So we label it exponential. And the equation is going to be y equals, the constant multiplier is 1/2. It's 1/2 to the x. And when x is 0, at the very beginning, when x is 0, anything to the 0 power is 1. And so the starting amount multiplies times 1 to give us the 40,000 it started with. So it'll be 40,000 times 1 will be what it started with, 40,000. And then every time x goes up by 1, we'll multiply by an extra 1/2. Number 3, Jeff has $100 and he gets $2 more every day for being awesome. Okay, so there's something constant going on, but it is not a constant multiplier. And it's not a constant multiplier because getting $2 more dollars each day isn't multiplying, it's adding. After one day, he has 102. After a second day, he has 104. This is a constant difference. This is actually a linear function, so this is not exponential, and we don't have to write the equation even though we could. All right, I'll do one of the tables. I'll do number 4, fine. The first thing to do is to look for a constant multiplier to see if it is exponential. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. Times 2 times 2. This is an exponential, and so we should write the equation for it. The constant multiplier is obviously 2, so it's going to be 2 to the x, but we need to multiply it by whatever the starting value was. And the starting value is when x is 0. 2 to the 0 is 1. What does it need to be multiplied by? Well, when x is 0, 2 to the 0 is 1, and it needs to be multiplied by 10. That is the y-intercept, and that's what goes here. So 10 times 2 to the x. All right, I'd like to do number 9 and number 10 here. Number 9, the point starts out at 0, 2, it says. And then we've got this point. It sure looks like it could be half of an exponential with a domain restriction. However, oh, you know what? Did we need a domain restriction here for this exponential number? We should say it's, let's go back up to number 2 real quick. This exponential only has a domain of x is greater than or equal to 0 because before she buys the boat wasn't worth $80,000. What this graph looks like is it starts at 40,000 and we end up with this exponential graph, but it's only half of an exponential graph because it wasn't increasing in value if we go back in time. So it needs a domain restriction here. And we're going to need that here if this is an exponential as well, because it's only half of a graph. The first thing to check is it exponential? And we need to check for a constant multiplier. 0, 2. This is 1, 4. So it multiplied by 2. The question does it keep multiplying by 2? When x is 2, this sure looks like 10. 10 times 2 is 20, so this multiplied by 2. And the next number is 34. So it multiplied by 2, and then it didn't multiply by 2. And then it multiplied by 2, and then it didn't multiply by 2. This is not an exponential, so we don't have to write an equation for it. In fact, this is a quadratic, and you can find the quadratic equation. On the other hand, number 10 starts at 0, 1. The next y value is 2. The next y value is 4. The next y value is 8. The next y value is 16. The next y value is 32. It's multiplying by 2 each time. Times 2, times 2, times 2, times 2, times 2. This is an exponential, and the equation is y equals, the constant multiplier is 2. So we're going to multiply by 2, by 2, by 2, by 2, x times. And the y-intercept when x is 0 is 1, so we don't need to put a 1 in front. It's just y equals 2 to the x. This is a parent function. Now we do need a domain restriction. This is only when x is greater than or equal to 0, there isn't the other part of the exponential back to the left. So that's it. On the back, we are supposed to create a table, a graph, and a situation. I will choose number 11 to do. X, y. When x is 0, y is 5, because that's the y-intercept, or you could just plug in. 2 to the 0 is 1. 5 times 1 is 5. When x is 1, 2 to the 1 is 2. 2 times 5 is 10. Or I could just recognize that this has a constant multiplier, and every time x goes up by 1, I'm multiplying by 2. That's a little bit faster. Okay. The graph is the y-intercept starts at 5, and it goes up like this. That's good enough for my graph. All right. The situation. All right. It has to be something where there's a constant multiplier of 2, so something needs to be doubling or multiplying by 2 each time, and we needed to start out with 5 of something. So I'm going to say Mr. Woodward has 5 students get A's in his class the first year he teaches. Ooh, actually, this will not work. And I'll tell you why this doesn't work in just a second. We'll check it. And the number who get A's doubles each year. This does not work for this equation. It's very close, but it doesn't quite work. And the reason is it says there are 5 students the first year he teaches. So if x is the number of years, it would say after 1 year, the first year he teaches, there would be 5. And so it doesn't quite match this. So I wonder if we can change it. Mr. Woodward has 5 students. I don't know. I'm going to get rid of this completely. Mr. Woodward starts with $5, and his money doubles every day. This example does work because when the time is 0, the money will be 5. So that actually matches instead of this first one, which was close but doesn't quite match. Hopefully that helps on your homework.